Tranquility Base here. The Eagle has landed.
Even before the Apollo moon landing in 1969,
That's one small step for man,
NASA began early studies of space shuttle designs.
one giant leap for mankind.
The primary intended use of the space shuttle was supporting the future space station. The United States Air Force was also interested in using the shuttle, and NASA welcomed their participation and influence, placing military astronauts in orbit. In turn, by serving Air Force needs, the shuttle became a truly national system, carrying all military as well as civilian payloads. There has been an Air Force presence supporting the shuttle program at the Johnson Space Center in Houston, Texas, since December of 1981. 150 people were assigned to JSC at the time. Only 5 of them are left, now a part of the Space Development and Test Directorate.
The people who are doing the engineering, the design work, are also the people who are turning wrenches, as you see right here. And it's a very unique environment. There's no other organization like this where we've got our small Air Force culture, but it is located on a NASA facility, and we are the interface to all of NASA manned spaceflight.
Our focus is, has been, and always will be the warfighter.
A program like this is important because if you don't start now, you'll never develop that technology for the future.
We're here at the Lyndon B. Johnson Space Center, home of the Human Spaceflight Payloads Office of the Space Test Program here in Houston, Texas.
This is representing our Payload Operation Control Center, which we're able to command to the payload from the ground when we're on orbit. We have the systems infrastructure, so we do the initial commanding to turn the payload on, get the experiments powered on, but then at that point we're able to turn it over to the various experimenters at their locations. This is a STP-H4 payload, and we've got 5 DoD experiments and 3 NASA experiments that we're all integrating into one payload assembly.
I think what Space Test Program provides to the research community is a quick and affordable access to space. Many people have used the Space Test Program to get their research into space. Many remarked that if it was not for Space Test Program that they would have no way to get this research done.
They flew their first experiment on STS-4 in June of 1982 and have since flown over 250 experiments on 114 missions, including the shuttle, foreign launch vehicles such as the Japanese HTV,
liftoff of the HTV-3 on its way toward the International Space Station,
Russian Progress and Soyuz, and the European ATV. Upcoming launches on the commercial SpaceX resupply missions to the ISS include deploying small satellites from the Falcon 9. In 1965, the Air Force was named the executive agent for the newly created DoD Space Test Program. The purpose of the DoD Space Test Program is to provide cost-effective ways for new technologies to be flown and tested in the space environment. This provides new technologies for future space systems or test components for systems in development.
And out of 131 shuttle missions that I've supported, including 9 dedicated DoD missions, there was a lot of technology flown that were able to be disproved so that the government did not waste their money, did not waste the taxpayers' money pursuing something that didn't show any promise.
It's really a fundamentally different way for the Air Force to approach space. And we take this rod and we push it through. What excites me for that is, we can prove out some of these technologies and then help benefit the military in these specific applications.
The current payload is STP-H4, which provides flight for 5 DoD experiments that will demonstrate a new type of space weather sensor, a low-power global data exfiltration system, a new active thermal management technology for future spacecraft, and a set of radiation detectors that will model the 3-dimensional radiation environment around the payload.
Everything that we're doing has some application in a future DoD system, and just seeing how technology is progressing and we can still jump one step ahead of our adversary, it feels very good to be able to be part of that and to know that what we're working on here 10, 15, 20 years is really going to make a difference.
The The Space Development and Test Directorate also teamed with NASA to provide spaceflight for 3 of NASA's payloads that would otherwise not have a means to get to space. This is an international collaboration since the Japanese have agreed to launch this to the ISS on their 4th HTV mission to the International Space Station.
Ignition.
Once delivered on orbit, it will be installed on the outside of the ISS by the space station's robotic arm. The experimenters can operate their individual payloads right in their own facilities, giving them the freedom to conduct their experiments directly. We're here at Mission Control Center, Houston, where the flight control team is flying the International Space Station. The Space Test Program is currently flying 8 experiments, both inside and outside the space station.
And when it comes time to do our experiment, our folks are sitting here talking in the ear of the flight control team here at Johnson Space Center and helping the crew through any anomalies that they may have with that experiment. There's another way that we get involved with the crew, and some of our experiments are on the outside of the space station, and they require an EVA or a spacewalk to either put them out there or get them back.
The Neutral Buoyancy Laboratory, the largest indoor pool in the world. Here, astronauts are provided pre-flight training on all extravehicular activity on the International Space Station, such as retrieving science hardware on the STP experiment.
So we participate in training of the crew when they're in their spacesuits and they're training on how to do this spacewalk. We'll be there in the control room, making sure they understand how to work our hardware, following the procedure, optimizing the procedure so they can get as much done in that EVA as possible.
Some of the newest technologies are too immature even to test in space. So one way to see how they might behave in zero gravity is on the Zero-G aircraft, or as some may call it,
the Vomit Comet. Really cool opportunity.
And basically then you look at space as this alternative place where there's no gravity. So when you're floating around and your hair's, not staying down and your stomach feels goofy, that has some real implications for physics as well, how materials behave and stuff. And that's what we're looking at.
I'm now on board the Zero-G aircraft as the STP experiments are being loaded and bolted down on this modified Boeing 727.
I'm setting up a position for myself so I wouldn't fly out of the setup at zero gravity.
The Zero-G aircraft simulates microgravity by flying a series of parabolas, which give around 20 seconds of simulated Zero-G. How you guys doing?
The way that these flights are most beneficial is when someone has an experiment where they want to pump a fluid, because fluids behave very differently in microgravity.
How's it looking?
Right here, looks awesome.
Is it what you thought it would be?
It is, actually.
And you can't really model that on the ground.
Now that the STP team is monitoring their experiments, let's have a little fun.
I look at it as an opportunity to just broaden my experience to become a better leader in the space business.
It's going pretty good.
Yeah?
We did the high G and low G version, and we did the fiber drawing as well.
Love it. And having some fun?
Yeah.
Good.
It's amazingly good.
Turns out, when you're in microgravity, your cells are under stress, just like when you get an injury in the battlefield. And so by flying these cells in microgravity, the experimenter can mimic that injury, and then they can test out different pharmaceuticals that allow that injury to heal faster. That was a highly successful experiment, actually, and that spun off into a technology that is in the use in the battlefield today. A small pump, an IV pump that an injured soldier wears on his arm, and it pumps fluid from an IV bag no matter what orientation you're in, whether on a litter or in the battlefield or on a helicopter. That was a spin-off of that experiment that we tested in the beginning on the Zero-G airplane and then later on the space shuttle.
The DoD Space Test Program has supported over 520 experiments in its 48-year history. These experiments have laid the groundwork for the systems our warfighters count on day in and day out to support their missions on the ground and in the air. The Human Spaceflight Office at the Johnson Space Center has flown DoD experiments on 105 of the 135 shuttle missions, and were the first to fly payloads on the International Space Station. They leverage their expertise to provide DoD experimenters with the access to space they need to develop the space technologies of the future.
If it's getting off the planet, we're going to have something on it.
Our focus is to get the payloads that we have currently in the mix off this planet to the International Space Station. We will work with the astronaut crews to get the science that we need, get it back to the payload developers and the scientists, and whatever comes of that science is going to give the warfighter the edge of tomorrow.